Kia ora tēnā tātou katoa. My name is Shane Clark. I'm the General Manager here at Neuralite. Neuralite is New Zealand's leading membrane waterproofing supplier. And welcome to webinar 37. Today's topic is KISS. So something I had to explain to the Gen Xers and or below Gen Xers what it actually stood for, which was keep it simple, stupid. More specifically, the topic is around how simplifying design can have a significant effect on the overall cost of a project. Now, this whole cost-conscious theme has been relatively popular, and we all want our projects to go ahead. So luckily for you today, I have some other people on the panel with me. Firstly, I'd like to welcome Benedict Paccarel, our Neuralite Technical Advisor. Dr. Benny has been with Neuralite for a short period now, but has some extensive background in construction, particularly around the sealants and coatings area. Benny will be covering a couple of design considerations, including, do you really need a gutter, and other considerations around things like membrane selection. We also have Sean Taylor, Director from Team Green Architects from sunny Queenstown, but cold down there today, I understand. Who will give us a rundown on her principles of keeping it simple, stupid. And she's got a bit of a case study there, I think, on a few projects, and she's going to talk to our design cost considerations in more detail. This webinar is set for 30 minutes. Towards the end, we'll have a short Q&A session. So feel free to pop your questions into the Q&A function at the bottom of your screen there, and we'll go through those at the end. We may not get to all of them, but that's okay. All the registered attendees today will get sent out a transcript with the full Q&A fully answered for you. Like all our previous webinars available on the education page, this webinar is also NZIA accredited for 5 points. So at the end of this webinar, we'll pop out a survey that you can pop in your name and your registration number, and we'll get that sorted out for you. We try and make these webinars as interactive as possible, rather than looking at my head talking at you for half an hour. So we're going to run a bit of a poll to kick things off with. So if you want to pop that up, Jen, the first poll is, have you ever had a project go on hold or stop altogether as a result of cost issues? And we're going to display the results of this to see who's in the room, basically. Excellent. I want to finish that up now. Do we get to display that? There we go. So yeah, 88% had a project delayed or stopped due to cost increase. Good to see. Thanks for participating in that. Right, so we're going to flick to our presentation now. I'm going to introduce Benny, who's going to talk to the first slide, which is an internal gutter. I'm going to flick to that next slide there. One more, probably. Here we go. Hey, Benny,
how are you? I'm good. Thank you, Shane. Kia ora, everyone. So looking at this illustration of an internal gutter, you can see that there is a complexity with angles, with additional framework, ultimately adding cost. PIR insulation must be cut into shape to fit into this internal gutter. Then NeuraPly 3PM is installed on top of the PIR with additional fillets to avoid sharp angles. All of this installation process takes additional time and material. Next slide. So
what's our alternative, Benny? We're not going to build in gutters. Might scare some people. Here, so what's the alternative?
So a simple design consideration is the removal of gutters. We suggest to remove gutters completely and design the roof with falls, which results in a huge cost saving. Remove gutters from decks and roofs and design the falls to outlets. To do so, one can use tapered PIR insulation or design the falls onto the substrates using plywood or concrete.
No, excellent. Sounds like a good idea. So a bit of a breakdown there of the system.
So as an example, this particular project came to us with traditional internal gutters in the initial design. Through our in-house tapered design process, we were able to remove gutters and create hip and valleys falls to outlets, which eliminated approximately 4 times 40 feet shipping containers worth of PIR installation, effectively a significant 6-figure cost saving. I mean, it was a big project, but it was huge cost saving. You can see on this slide the tapered PIR installation being supplied with a 1-degree fall, which will facilitate falls to the outlets.
No,
Any question?
excellent. Yeah, just we're just going to, just before we, oh no, we can cut on to membranes and then we'll run that poll at the end. But no, carry on. What's another design consideration you've got, Benny?
So now considering the type of membrane you wish to choose, this illustrates a wide sheet of Nuraply TPO versus 3PM. Nuraply 3PM is supplied as a 1 meter wide times 7.5 meters long, whereas TPO membrane comes in 3.6 meters wide times 30 meters long. Comparing these two membranes on a wide roof, you can see that there would be less laps installing TPO membrane.
Yeah, no, they definitely look a lot bigger. So you've got an example here of where you would use one particular membrane over another.
That's right. So on this roof, Nuraply 3PM was used. It is a robust 2 layers bitumen membrane system with a mineral chip texture finish. First layer is self-adhered and the second layer is applied with a gas torch. Nuraply 3PM is ideal for roofs where 1 degree fall is required or for a complex roof geometry, roofs with plant areas or a lot of details. The membrane system being bitumen-based tends to be easier to install around details and busy roof areas.
Yeah, no, nice. It's a very thick and robust membrane. It's you can, I don't know if you can quite see on that slide, but this particular roof also has a living area sort of in the middle of it with Eurojacks and whatnot. But
that's right.
So yeah, it is a well-used area.
That's right.
Go to the next slide. We've got another example.
Yeah, so here you can see the Nuraply TPO, which is ideal for large-scale projects. It is a single layer membrane with a smooth finish. This membrane requires a 2 degrees fall. It uses hot blown air applied from an electric heat gun. So for a large, simple roof, we would advise TPO being wide gives a fast coverage and less laps.
Excellent. No, thanks for that, Benny. So yeah, a couple of design considerations there around elimination of gutters and your membrane selection. I'm going to run a second poll now to make sure we're all still wide awake. And just wondering if anyone's ever actually, before now, actually considered not, eliminating a gutter as a cost-saving initiative. See if it's been considered before. So we'll let that run for a couple of seconds. Cool, please, Jim. Oh, cool. It's I'd say that's 50-50. Interesting. Excellent. Okay, I'm now going to introduce Sean Taylor, like I said, from Team Green Architects. He's going to talk about some simple form and design ideas and around how keeping it simple can be of benefit to you. Morning, Sean.
Hello. Thanks, Shane. Ian, can you just go to the next slide? Thank you. So thanks for inviting me to talk here today, guys. It's a real passion of mine, this particular subject. And the reason for that is that I think we're at a time as architects and designers, but anyone in this industry where everything's challenging. Everything's costing way more than it should, and it's continually increasing in cost. Everything's taking a lot more time, and it all seems to be getting much, much harder. The process is harder and taking longer. It's harder to get clients because they know it's costing a lot more money. And this is all at a time when we also desperately need to make our buildings more sustainable, which is my particular passion. So these three major challenges can seem insurmountable, which is why at the moment I'm trying to do as much as I can to get a message out there that actually the things that make the biggest difference to sustainable design are often the things that can save our clients money or reduce the cost of the building. And we already know what we're doing. So it's not as challenging as it might seem. I think with the fact that we've got to do things like start counting carbon, etc., it seems like it's hugely challenging. But the more modeling, energy modeling, carbon counting, etc., that we do, again and again, we're seeing that the low-hanging fruit is the stuff that we already know. It's the stuff that actually is relatively easy for us to do. And this principle of KISS, keep it simple, stupid, is one of the key principles. So Yin, can you go to the next slide? So these are the three principles that I'm sort of emphasizing at the moment. I'm only going to be talking to number 2 today, but these are the three things which again and again we see are saving money and ultimately saving carbon. So optimizing orientation, keeping it simple, and building less and choosing well. If you go to the next slide, please. So in anticipation of this talk, I typed in 2 things: complex building and boring building. So neither of these are mine. And I'm not going to comment on the architecture, but I guess I kind of am commenting on the architecture. But this is what I see is, I guess, a challenge that we face as architects and designers, is that we don't want to create something that's boring. So by saying it's simple, we don't want to have to create something that just is boring architecture. We ultimately like creating buildings that are interesting, architecturally interesting. But obviously the challenge that we face with complexity is that ultimately it's going to cost more money. It's going to cost us much more money in terms of design, time, detailing, etc. And ultimately it's going to cost our client more money because it takes longer to build, it's more complex to build. And ultimately the complexity adds to the cost and the carbon of that building, which is what I'm going to talk to here. But at the same time, we don't want to create boring buildings. So it's the art is that balance of the two. How do we achieve a simple building, but still create architectural interest? If you go to the next slide, please. So complex form, what does it do? So obviously the big thing that it does is that it increases materials. Benny just talked to that in terms of the gutters, but that's the same around the entire building. The complex geometry is going to increase materials, both in terms of how to create that geometry, but also significantly in terms of the waste. So the more complex the geometry, the more waste that you have on the building site. And obviously when you've got waste, you can separate the waste, as is shown on this image here, but ultimately offcuts have limited reusability on a building site. And all the carbon that goes into creating those materials, whether they be timber structural elements or cladding elements, whatever it may be, that is stuff that's taken embodied carbon to remove from the ground and to manufacture and then bring to site. And then if it's just chopped off and then put into a bin, it's just a complete waste of all of that carbon that is taken to produce it. And obviously cost, it's an unnecessary cost. But the other big thing is obviously increased risk of failure. So the more complex the geometry, the more risk there is to the building failing. And that ties directly into climate resilience. So all of this is around the fact that our climate is increasing in temperature, which is the biggest challenge that we're currently facing. But with that increase in temperature, we get extreme weather conditions, we get extreme weather patterns, increased rainfall, increased wind, etc. And so the more complex our buildings are, the more risk they are of failing. So if we've created a building that ultimately is going to fail in a smaller period of time because of this change in climate, then we haven't created a building that is responding to this climate change conditions. And it's ultimately then a huge amount of carbon that's just going to be completely wasted, because the building would need to be reproduced, rebuilt, or just clad, or whatever it is that you're going to have to do. So it's cost and it's carbon every single time. Next slide, please. So what does Simple Form do? So Simple Form, obviously, it does two things in terms of carbon. It reduces embodied carbon and it reduces operational carbon. So that's what I'm going to talk to here. So in terms of embodied carbon, the main thing that it does is it reduces the amount of materials, because the simpler the form, as we just talked about, the less materials you have to use to create that complex geometry. And that therefore links directly to the amount of embodied carbon, because the less materials means less embodied carbon. And I thought that often certainly occurs to me, and I think it occurs to many of us, is when we think of embodied carbon and reducing embodied carbon, is that it's going to cost more money. Because one of the biggest things that we look at is the fact that structure, for example, to reduce embodied carbon in terms of structure, we have to start looking at things like timber structure, because the three biggest sort of embodied carbons are the concrete, the steel, and the aluminium. So coming away from that, if you've got a timber structure, it costs a lot more money, because you need much more bigger timber elements to create the same spans, etc. So what we have to do to further reduce cost in embodied carbon is simplify our design, simplify our buildings, because that means less materials overall, and it means that we can, the builder can look at things like repetition, easier to build, reduction of waste, reduction of offcuts, etc., just to create that that same building. And things like the cladding, because ultimately the simpler the external envelope, the less cladding materials we also need, and ultimately that reduces cost.
Sounds so simple, doesn't it?
Yeah, I should have said that. This is trying to keep it in our heads as well. So
yeah.
Okay, so then operational carbon, the fact that a simpler structure, how this reduces operational carbon. Essentially, this is about the form factor. So the form factor is the surface area of a building relative to the gross internal area of the building. So the bigger that number is, the harder that it is to create a low operational carbon building. And the reason for that is that operational carbon is directly linked to heat loss and heat demand of the building. And that is across our entire climate. So that's the same up in Auckland, obviously to a lesser degree as it is to us down here in Queenstown. Heat loss is the biggest portion of operational carbon. So to reduce that, we have to reduce our surface area, places where we can start to lose that heat. And a simpler structure means that you're going to reduce that operational carbon, you're going to reduce that heat loss. But it also means that you're going to reduce embodied carbon, because if you're trying to achieve a certain level of operational efficiency and you have a complex geometry, you need more materials to reduce that operational carbon, because you need more materials to reduce that heat loss. So a simpler surface area, the way I try to explain it to people is it's a bit like if you're on the mountain and like you do here, go skiing and it's freezing cold, you don't sort of sit there with your arms out wide, you sort of huddle in nice and tight.
Depends how good a skier you are, I guess. Yeah.
Yeah. But if you're but if it's cold, you don't want things like your hands out in the cold, because they've got a huge amount of surface area relative to the internal volume and they get really cold. Same is true with a building. The more junctions there are, the more geometry there is, the more surface area that there is on the outside of the building for heat to seep out. And also then to avoid things like cold bridging and potential places where you can have condensation and mold growth. So the simpler the structure, the more durable the building is, and the reduced operational costs and operational carbon, because the two are obviously linked. Next slide, please.
Awesome.
Yeah, so ultimately this is the final one, and as I said at the start, the idea is to try and achieve a building that is a simple form. So each one of these buildings, these are buildings that we designed. Each one of them is a 2-story rectangle, essentially. They may not look it, in particular this one on the top right probably doesn't look it, but each one is using the shading elements of the building to create something that is more architecturally interesting, hopefully, but the actual thermal envelope behind that is a 2-story rectangle. And ultimately, so the other big thing that we need to start considering as the climate increases, it has been estimated that by 2050, 50% of greenhouse gas emissions are going to be due to cooling requirements of our building. So I'll say that again. By 2050, 50% of greenhouse gases will be due to cooling of our building, which is huge. So as the climate increases, as our buildings get more efficient and as our heat loss gets reduced, actually we've got this converse problem, which is that our buildings are going to become too hot, and we need to shade our buildings appropriately, and we need to do that on the outside of our buildings. So we need to stop the heat coming in, so that we don't have this huge cost, operational cost, but also operational carbon because of cooling our buildings. And therefore we can do the two things at once, which is hopefully what these buildings here are doing. We're creating shade with building elements, but keeping the building really simple. The thermal envelope behind each one is just a simple rectangular structure. And that's it.
Great. That is amazing. Thanks, Sian. It's great to see that, simple form doesn't need to be boring. That's great. And personally, we love your work, and some of you may realize that this is not Sian's first webinar with us, because we're a huge fan of what she does, particularly around the sustainability and the passive house type attributes that are in the building. So thank you for that. We've got time for a few questions in the Q&A. We've had a few come through, appreciate that. We'll see if we can get through a few of them. Got one here. Benny, you mentioned that the fall in the tapered PIR board was 1 degree. Question is, how does that comply with the building code?
So that's right. For NeurApply 3 PM membrane, we have a CodeMark certificate for fall of 1/80, effectively 0.7 degrees. So 1 degree angle, which is the PIR, tapered PIR fall, it does comply with the code.
Yeah, great. So I guess with the CodeMark, it's nice and easy for consent too, which is beneficial. What have we got here? Here's one for me, actually. Cost. Everyone wants to know the cost comparison. Someone's asked the cost comparison between 3PM and our NeurApply TPO. Basically, a square meter of bitumen and a square meter of TPO membrane is basically the same price. Product cost is around about the same price. But Benny, you've got some information on so where the saving comes down is the type of building that's used on, and Benny, you got some information on the
that's right.
Yeah,
because I can see this question as well. It's considering associated carpentry, etc. So if you lay a NeurApply 3 PM membrane, it'd be 1 meter times 7.5 meters, so it'd be 7.5 square meter. It takes 20 minutes to lay the first layer, self-adhere to the substrate, and then torch on the second layer. If you compare with TPO, it takes the same time, 20 minutes, to lay a roll, which is effectively 100 square meter. So on a because it's very much depend on the roof, and that's why we always encourage our designer to reach out to us at the early stage. But so to lay a 100 square meter of a simple shape, no details around it, 100 square meter of TPO versus 7.5 square meter of 3PM. They both take 20 minutes.
Yeah, right. So we're talking about a very, a typical flat piece of roof. Nothing. We haven't accounted for any particular detailing or things like that. So there is no one silver bullet, which is unfortunate. Otherwise, we'd only have one product instead of 1,200. So yeah, like Benny says, get in touch with us and we can sort of advise you on the best for your particular situation.
Just add one comment. So in Auckland, we see a lot of quotes coming through from our approved applicators. And a lot of the time when it is a complex geometry roof for a smallish residential project, then 3PM installation would come under TPO because it's easier to install on complex roofs.
Correct. No, absolutely. Just more of a comment here from someone's a designer's own experience that the tapered PIR board is expensive. Again, it's horses for courses. To be honest, the most economical high performance roof you can do is a Neurotherm warm roof on metal tray, and pitch the metal tray to the floor. We covered that in a previous webinar, but actually webinar in 4 weeks' time, we're doing a deep dive into substrate selection and whatnot, and how that can have an effect on the overall cost. PIR comes into its own for that example that Benny used, where we're using a flat CLT panel. So the CLT panel is actually the ceiling inside the building, so they wanted it to remain flat. So we've had a good old flurry of questions in the last 2 minutes. We won't get a chance to answer them all, but like I said, what we'll do is collate them all, and they'll all go out to all the people that are registered, and we'll answer them in full. So yeah, I just want to wrap up and say thank you very much, everybody, for attending. I do know that Benny's arranged some of her practices to sit in the boardroom and share this presentation all at once, and she has managed to shout the morning tea. So if you want to send us a photo of your team sitting down in the boardroom watching this, we'll arrange that for next time as well. That was our webinar in our series of cost-conscious design and how true value engineering occurs at the design stage. Today's webinar was how to keep it simple, stupid, and we hope we've picked up some good tips there. And one last poll before we go. If you're currently working on something and you'd like someone to follow up with you in the team to see if we can offer any cost-saving creativity, feel free to give us a note here, and we'll follow up with you in due course. So yeah, that was us. That was our webinar on keeping it simple, and I look forward to seeing you on the next one, which will be around the same theme. Thank you, Sean. Thank you, Benny, and thank you to the producers. Wonderful, and we'll see you on the next one. Thanks, guys.
Thank you, everyone.